Pediatric and adult dosage based on body weight. So anyone that is administered drugs, if you're a caregiver, a health provider, whatever you may be, you're legally responsible for recognizing incorrect and unsafe dosage. So it's very important. The children aged birth to 1 year have a high percentage of body water. Children aged 1 to 12 years metabolize drugs more rapidly than adults. So I'm not going to get too deep into the science on this at all, but I do feel this is very, very important. It's very crucial, not just for the health programs, but for anybody that's a parent or a caregiver of a grandparent, friend, cousin, whatever you may be, a spouse. If you're going to be taking care of someone as far as their medication goes, I feel this is very important. So I'm going to skip on to the math part, okay? So I encourage you to read up on it. This here is a quick reminder. 1 kilogram is approximately 2.2 pounds. Of course, I asked y'all not to use the S in this class because when you handwrite, sometimes the S will look like a 5. It says 1 pound is to 16 ounces. So when converting kilograms, we're going to round the kilograms to the nearest tenths. Okay, so when I told y'all the rules on rounding, I said only round the kilograms in weight to tenths if and only if I said a patient weighs 116 pounds, what is that in kilograms? Then we're going to round it to the nearest tenths. But whenever I'm calculating if it's safe or recommended, I am not going to do that. I'm going to stay with whatever number it gives me, so that way I could be closer to the most accurate reading as far as what I should recommend or not. So this one says, let's convert 45 pounds to kilograms. So we say we have a patient that weighs 45 pounds. What we're going to do is we're going to take that 45 pounds. It's my patient, right? And you can set it up in formula method or dimension analysis. I'm going to do dimension analysis. I'm going to put it over 1 because it's just one patient. And I know that I need a conversion here to go to kilograms. And I'm going to use approximately. And we know that 1 kilogram is equal to or is equivalent to 2.2 pounds. So I'm going to go through here and mark the pound down, right? Now I'm left with 45 divided by 2.2. And this is going to give me kilograms. And then when I divide 45 by 2.2, sometimes we come out with a clean decimal, sometimes we do not. Not always. So I come out with approximately 20.45, and this is repeating. So I asked you to round to the nearest tenths. The tenths is the first decimal place right here. And we are asking to round a patient's weight. So we have to look at the number behind it. And we ask ourselves, the number behind the tenths, is it equal to or greater than 5? And if you say yes, then we're going to add 1 to this tenths place. If you say no, then we just drop it off. In this case, it is yes. So my answer is rounded 4. Add 1 to 4, it's rounded up to a 5. And now I got 20.5 kilograms for this patient. So this one here says, what if I have a patient that weighs 10 pounds, 12 ounces, and I want you to convert that to kilograms. Again, we know the relationship between kilograms and pounds. Okay, forgive me, I didn't give enough space between the unit and the number. That would be something I have to clean up. And I wrote over that. So that's not a really good writing, guys. Let's just rewrite it. It just was not a good writing. So 1 kilogram. I'm going to say approximately. The book says equals, but I mean, truth of the matter, it's approximately. All right. So since we know that, what I need to do is take this 12 ounces and I need to convert it to pounds. So I got the 12 ounce. I'm going to put it over 1, but if you want to use formula method, you can. And I know the relationship between 1 pound is equal to 16 ounces. So I need the 16 ounce on bottom here and the 1 pound on top. And what does that give me? It gives me 12 divided by 16, and it's in pound. So when I reduce this, I know that 12 and 16 will reduce by 4, and it's going to leave me with 3/4 pound. And now I need to convert that to decimal, and 3/4 pound is 0.75. And we don't want to do no rounding right now. Okay, so I'm going to take the 10. Let's scoot over here. I'm going to take this 10 pound, and I'm going to add the 0.7 pounds. And remember, whenever we add or subtract, we should line up the decimal. So let me rewrite this a little neater. So that means I need to come up here and put a decimal here, and you have to put zeros just because I'm adding, right? Some of you already saw the shortcut and already know the answer. Okay, so this patient weighs 10.75 pounds. And what we're going to do is we're going to convert that to kilograms. So I'm going to take the patient. And I'm going to do a quick reminder on how to do formula method for those of you that forgot, that wants to rehear it again. And I'm going to put it over the equivalent unit out of the needed conversion. Multiply it by its quantity, which is 1 kilogram. And then we're going to go through here and we're just going to mark out the units that we don't need. The LB, they worked out. That worked out great, so we did it right. And now I have 10.75 divided by 2.2. Double checking my math. And it gives me 4.8836 repeated. The 36 is repeating, and it's kilograms. And since I asked about a patient's weight, then that means we're going to round to the nearest tenths. In order to round to the nearest tenths, we need to ask ourselves in the hundredths place, and yes or no, is it equal to or greater than 5? And you say yes, so that means we need to add 1. So now we can say that this patient weighs 4.9 kilograms. That's a little baby, huh? Well, that's not, it's a big baby, but a little baby. So now let's go on to this next one. This next one says we have an order of 1.8 milligrams intramuscular stat. We have this child who weighs 79 pounds, and we want to know, is this going to be safe for that patient? Well, I need to double check. I believe there is a question missing. I pulled this from the textbook. I apologize. Let me find the supply right quick. All right, so here I got the supply. For whatever reason, it's not on the slide. So we are missing a little bit of information. I recommended, and I'm just going to abbreviate, is 0.05 milligrams per kilogram per dose. Whoops. Write this a little bit smaller, guys. So let's go milligrams per kilogram per dose. All right. So my pen's, I apologize guys, my pen's not working, so I'm using my mouse, so my writing is not as great as it could be. Thank you for bearing with me. So now we're going to solve for it. We want to know, is this order safe? Did the doctor recommend a safe dosage? Well, we need to take the patient's weight, because look, it's based upon weight, the recommendation is, and calculate how much this patient can take. Now, if I was to use this example in our class and I said that I want you to determine if it's safe for you, we'd all have to take a different amount because we all weigh something different. So what we're going to do is we're going to take the 79 pounds. I'm going to set it in dimension analysis. Y'all can, again, set it in formula method. You can factor in groups. You can solve it in groups. It's fine. I know that for every 1 kilogram, it is approximately 2.2 pounds. So I'm going to come over here and I'm going to put in my needed conversion because I need this in kilograms. So I know it's 2.2 pounds here in the bottom because the pounds on top. And I got kilograms up here. And if you're ever in doubt, make sure you can reduce it and you're left with what you want on top. You did it right. So now what I'm going to do is I'm going to plug in my recommended. Now remember this, the milligrams, this first part of this here always goes on top, the rest goes on bottom, okay? And what happens? I'm able to go and mark out the kilograms and I'm left with milligrams per dose. This is going to give me my answer, right? Is this safe or not? So now what I got left with, I have, clean this up. I have 79 times 0.05, right? And then we're going to divide that by 2.2. And it's going to give me a 1.7954 repeated. The 54 is repeated milligrams per dose. And in this class, I asked you to round to the nearest hundreds whenever we're doing specific types of dosage calculations. So if I round this to the nearest hundreds, I'm going to have to look at the thousands place, right? And ask myself, yes or no, is it equal to 5 or greater than 5? And you say yes. So that means we have to add 1 to this 9. When I add 1 to this 9, it becomes 10 and carries a 1 over, right? So this becomes approximately 1.8 milligrams per dose. So here's the question, is it safe? Did what the doctor ordered, did this number here exceed the recommended? Meaning, did the doctor order more than what the recommended called for? And if your answer is no, then it's safe. And in this case, it's exactly equal to. It didn't go over it. It's exactly equal to. So it's safe. Now, some of y'all may be, if it's a young child or an older adult, a senior citizen, there is underlying issues, or just a regular a person in health issues. Since it came out like this with this number here on the back, and you're kind of leery about going ahead and rounding, then I would go speak to the person that wrote the drug order out, you know, because it is like right there on the line. But usually in some cases, it would be safe. Okay, so I'm not going to get into the science of it. I just want you to recognize that sometimes you might have to still ask questions about this. Okay, so you can practice on solving some of these. So let's talk about body weight. To verify a safe pediatric dosage, convert child's weight from pounds to kilograms, and we're going to round to the nearest tenths. Well, again, whenever you're just giving me the answer of the child's weight, yes, it'd be rounded to tenths. But if I'm still calculating if it's safe or not, please don't round, okay? So definitely read this chapter, read up on this information, and let's see if there's another example right quick. All right, here's another example. Yay. So it says we have an order of 200 milligrams by mouth every 8 hours for a child who weighs 22 pounds. So our first step is going to be, we're going to have to convert the child's weight, right, to kilograms. So I could put a 1 underneath this. I'm going to convert to kilograms. And some of you are asking me, how do I know this? Well, how do we know it? It's when we go to the slide with the recommended, it has a recommended max. And that recommended max is based upon milligrams per kilogram per, let's see, is it dose day per day? And it's got the same for the men. So it is important. And we gotta be careful when we abbreviate minimum because it looks like a minute if we take this I off the end of it here. So now when I say 22 divided by 2.2, we get 10, and it came out nice and pretty. So, I mean, there's no rounding here. We would not put a decimal and a 0 behind it. This is done. So we know the child weighs 10 kilograms. Now, I'm going to go to the slide, kind of skip a little forward. It says that we have a recommended dosage for this child of 20 milligrams per kilogram per day to 40 milligrams per kilogram per day. And it says it's divided in doses every 8 hours. So if it's divided in 8 doses every 8 hours, we know there's 24 hours in a day. And we're looking at 8 hours, every 8 hours, right? Well, how many settings would that give me? Every 8 hours we have 1 dose. So I did, that's formula method. Here's dimension analysis. Okay, so this is, you can use either methods, guys. So mark the H, the H, the H, the H. Okay, so 24 divided by 8. 8 goes in 24 3 times, so it's 3 doses in a day, right? So I showed you 2 different methods, give you the same answers. And look, they already gave you this here. So in 24-hour setting, we're going to do 3 dosage. What we need to do now is we need to find out what's the minimum and the maximum this child can take, right? And this is weighed in per day. So we have to factor in the fact that they're going to do 3 doses, right? So we already did that here. So that was part of my my equations I would have used. So in this place here, I could say 3 doses because we already did that math. So what I want to do next now is I want to solve what is the maximum and the minimum. I'm going to start with minimum. So we got a patient who weighs 10 kilograms. I'm going to put it over 1, or you can use formula method. And we got a minimum of 20 milligrams per kilogram per 3 doses. Oh my, I really need to get my ink pen working for this. Here, I apologize, guys. Thank you for bearing with me. Okay. So now what I have 10 times 20, and I can mark out the kilograms. So 10 times 20 is what, 200? And it's milligrams. And I'm going to divide that by 3 doses. Okay. So now 200 divided by 3. I'm going to round to the nearest hundreds. Or Did this ask you how to round? Did it say round to the nearest? It said round to the nearest tenths. So I'm going to round to the nearest tenths just because the question called for it. So for this patient, they can take around 66.7 milligrams per dose. That's the minimum it can take, and it'd be effective. If it goes below if the doctor prescribed less than that, then that means for this patient, then that means it might not be effective, or there might be something with that patient that's tolerance level or something. There's many different reasons. Could be. I'm going to erase this math that I showed you how to figure out how to break down the day into the per dose. And now let's do the maximum over here. Got the maximum. Again, I got this patient who's 10 kilograms. And put over 1. I'm going to multiply that by the maximum, which is 40 milligrams per kilogram. And again, we figured out how many doses in a day. Okay, so now I'm going to mark out the units. Let's multiply across. 10 times 40 is 400. Divided by 3, and it's milligrams per dose. So I got 400 divided by 3, and it gives me, and we're going to round to the nearest tenths because this is what it asked for. So my maximum is 133.3. So here's my max, and here's my minimum. So we need to go back to the order, and we need to see if it's safe. The doctor ordered 200 milligrams by mouth every 8 hours, so in a setting of 3. So what did we figure out? We figured out that the maximum amount for this patient to take to be safe is 133.3 per dose. And we noticed the doctor prescribed 200. So the answer to this is it's not safe. And you would say more than not safe. You would say because the exceeds the maximum or is greater than the recommended maximum amount this person can take. Now remember, if everybody in the class was to calculate their body weight based upon this, some people it'd be safe for, some people it would not, right? Because we all weigh different. So that is solving for body weight, using body weight, guys. So definitely review this section, go over it, practice problems, and ask me questions. Thank you.